Hello dear students. Some of clarification I need to give you about Nyquist criterion. So here when you are observing it, you can see that it is Nyquist contour. What is Nyquist contour? That you should understand. Nyquist contour is nothing but a contour that covers entire right hand of S-plane. So this is drawn in S-plane, sigma plus j omega. It is the contour that covers, encircles entire right half of S-plane is known as Nyquist contour, that is drawn in S-plane. And you already aware that omega varies from minus infinity to plus infinity, and that is represented by a C1, and C2 is an arc with a radius tending to infinity, and it is represented, arc is represented by r into e to the power of j pi. Pi varies from plus 90 to 0 to minus 90. So this is Nyquist contour, that is in S-plane. So this you should understand. It covers entire right half of S-plane. Why it is covers entire right half of S-plane? You know that if there is a pole, on the right half of S-plane, or if a pole is situated on the right half of S-plane, then you can understand that that is an unstable system. So in order to check that, we are considering this Nyquist contour, and for each problem this Nyquist contour is mapped into Q of S plane, that is on U plus JV plane, or Q of S plane is nothing but U plus, real axis U and the imaginary axis V or JV. Now this Nyquist plot. This is known as Nyquist plot. The previous one is known as Nyquist contour. The Nyquist plot is nothing but it is a mapping of the right hand of S plane to the Q of S plane. Suppose if the contour encircles minus 1 plus j0, then the system is stable. If it is not so, it encircles minus 1 j plus 0 in counterclockwise directions, then it is stable. So you understood how we, in the previous problem we got you understood how we got the Nyquist plot. So that is the difference between Nyquist contour and the Nyquist plot. Nyquist contour defines all possible conditions for the instability, and suppose if there is a pole in the right half of S-plane in an open loop transfer functions, when it comes to a closed loop, this is an example, when it comes to a closed loop, then you can see that the contour, the Nyquist plot encircles minus 1 j0 in that problem, that is 8.2 problem. This is an 8.2 problem plot. Then you can understand that it is stable. In open loop transfer function, it is not stable, but when it comes to the closed loop transfer function, it is stable. So we did a mapping of Nyquist contour to the Q of S plane and we check the condition, that is whether it is stable or not. That's only.